start the recording. Anybody have any questions that y'all want to go over?
Yeah.
Okay. All right, what y'all got? Yeah. Oh, by the way, for that question yesterday, I asked one of my coworkers, yo, we on the same page. You don't even know how to do it.
See,
Yeah, like that joint is real. Yeah. I mean, like there's a trick that I'm using to answer it, but I'm trying to do it legitimately, like a legitimate way, but I don't know how to do it a legitimate way. Nah, it's still gonna be on the homework.
these signs change.
Oh, whenever you divide or multiply by a negative, it flips the sign, right? So let me show you. Um, do you agree if I say that 2 is less than 5, right? You agree with that? All right. So now let's say that I multiply both sides by like -2. Just making it up, right? So times -2. I don't even look like times -2, but I'm put a dot. Dot -2, dot -2, right? So this will become what? -4 less than -10. You know that ain't true, right? If you owe $10, right? That's you having less money than you own for. So that's a false statement. That's the reason why they flip. Yeah.
Okay, because I did this problem like 5 times and then I just flipped the signs and then it was right. I just didn't.
And you were supposed to. Yeah, that's what you were supposed to do. Yeah. That's actually what we're getting into today. Anybody else? Mm-hmm. All right, cool. 2 questions works. All right.
Okay, this is the
Mhm.
first one. Now I know the mean even one. So what I did, and the tutor, they taught me how to use this paper here.
So
So I added all of these together.
let me do the first one. After you see the first one, the rest of it is the same thing. It's just like repetition, you know?
That's what
There you go. So there's a formula on the formula sheet, right? The first one is the mean, mu, right? The formula is N times P. It's in chapter 6 on the first page, right? So you just plug in those numbers. So it's 3 times 0.5. I feel you. I feel you. Are you sure you don't want the cough drop?
Let me get that just in case I get sick fast, like. Well, I think avoiding.
I know at some point I'm gonna be talking and I'm gonna just like go off.
I got the chills, girl. I'm feeling like the flu. Oh my God. I don't think I should be here. I'm ready to go.
I mean, you already know it's recorded, so.
Yeah, I'm gonna go. Come on. That should make me sick.
I caught the flu and I was done.
No, I'll be me, bro. I don't even get bad. Like,
I don't think
that's
that's
my life up.
Yeah, but you know when you have it, cause you can feel like I feel the chills or my body.
You taste like it's hard to taste. Yeah.
So.
Feel better, babe. Oh my God.
There you go. Got you.
Yeah, I'm about to go. That's all I've been doing. I'm about to take the stir flu in my bag. Yeah.
My fault. I don't know why the paper came off with this.
So today you should have did the online. They said, oh, can recover.
I'm not gonna lie to y'all, like I love online.
Me
but,
too.
But I know not everybody in here might like it though.
Shoot, I could go an hour after. I was around how I love online.
And I'm same with me. It'd be like an hour to travel.
Where?
Yeah. I see you. Okay. So for the first one, right? Literally just multiply it, right? So this is 3 times 0.5. Right?
How you doing that?
Just multiply it, that's all.
So I didn't have to go find it?
No, that's right here. So
No, I meant the numbers, the standard, whatever.
no, they gave it to you.
No, because when they said it's like that, you have to go over
And
No. That's for the probability. But they're not asking you that. They ask you what is the mean, what is the standard deviation, what's the variance, right? So the variance, right? This is gonna be n times p times q. Or you can rewrite it as n times p times 1 minus p. And you just plug in the numbers. That's all it is, right? So this would be like 3 times 0.5 times 1 minus 0.5. A little math, boom, boom, and then that's it, right? Let me see. That'd be like
U is P
three.
minus one.
Q is 1 minus P.
I think you did this and I understood.
Is it 0.5? Yeah. You understood it? Good, good. All right, so then this would be like 0.75. And then the standard deviation is always the square root of your variance. So you just square root that number, and then you're good to go. All right?
I can do that on my hand, right?
All on your calculator, yeah.
Oh,
And then this big decimal, that's your answer. And that's it. Mhm.
yeah. Okay, so I don't have to. Okay.
And the rest of them is the same thing.
Same.
You just plug in the different numbers and that's it. Yeah.
Thank you so much.
You're welcome. Thank you.
Because what are you criticizing my essay and then you don't even tell me how to convert it? This doesn't make any sense.
Ain't that true? They never teach you how to write.
Just teach me how to write.
Good. Yo, I still remember when I went to high school and it was like, yo, write this essay, but they never taught me how to write it. Yo, you know who taught me how to write? It was when I took English 112. That was the first time I ever learned how to write. Like this is how you structure the essay. And all. Yeah, yeah.
Whoa.
That's intense. Yeah. But you know what's my new thing now though? Yo, I love AI for this, right? Because with AI, I ain't got a structure. Jack. AI does it all for me. Who said you can't do that?
He says that right in all. They do say that. They say
Write it in your words, right? But you could use it to structure the thing for you. That's what I do. Yeah.
he gives us a topic, and then from that topic, we gotta write what we think about it, you know? How we can compare to it.
Like let me give you an example, right? Like y'all see the announcements that I be posting for class, right? Y'all notice how the announcements in the beginning were versus how they are now? That's AI, right? Like remember I used to have like a whole paragraph for you to read through, and now all of a sudden it's like a couple of sentences that you're reading, right? Like so when I'm doing my AI, right? I write that paragraph straight to AI. Like, yo, tell them about this, and this, right? Like I'm detailed, right? And then AI just simplifies it into like a couple of lines with some emojis, and it's the same thing I was trying to say. You know? Yeah. Yeah. Mhm. Yeah. Yo, even that AI could do the memory map. That's another thing. Yeah. Mhm. Yeah. Oh yeah, yeah. Yeah. Right. Yeah, definitely. Let me see. Yeah, I got you. Like frustrated. I got you. I got you. Yeah. Yeah. Got you. Yeah. Next class, bring your laptop and let's see. You know. Also, when we do our online class, you can just share your screen. That's another thing we could do. You know? Yeah. I got you. I got you. With the slope homework and all that. Yeah. Yeah, yeah. 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 I got you.
For some odd reason,
Yeah.
he's like, okay, do it by yourself. I got more than right. I did this.
Nice. Nice. That's good. That's good. At least, as long as you understand, that's what matters. Yeah. Yeah.
So I think I feel
Mhm. Yeah.
Yeah.
Nah, you be on point with your homework. For real, for real.
So, because the website people glitching on my side.
But the thing is that you see, if I'm correcting it though, like it's wrong on the first try. But this way, it's like you can just try it and try it until you get it right. You know? Yeah.
And I did it. Because you see how sometimes you kind of like one of the points was zero, but it was a totally different answer. That I'm trying to
Yeah.
If I'm giving
Yeah.
you the
I
answer.
explained it, didn't I? Because they don't exist at the same time. All right, let's look at today's lesson. All right, this is gonna be a real easy, smooth, not quite, chapter 4. All right. Yeah, we're going back to algebra for a little bit. Yeah, because we got to before we could go forward, you know? So, all right, we're going to be doing solving linear inequalities in one variable. All right, pretty cool. So, a linear inequality, as its name implies, is an inequality in which the only operations involving the variables are addition, subtraction, multiplication by a constant. In this section, we consider inequalities with just one variable. Like equations, inequalities can be true or false. Solving an inequality involves finding all the values for the variable which makes a statement true. A look at a very easy example of a linear inequality shows a significant difference compared to linear equations. Consider, for example, the linear inequality x is less than or equal to 2, right? Notice that the variable is by itself on one side of the inequality and with no other operation involved. We can see by inspection that 2 is a solution, right? Because 2 is less than or equal to 2, right? That's true. Notice that x less than or equal to 2 is a compound statement. It is true when either x is less than 2 or, right, it is true when x is equal to 2. But 2 is not the only solution. For example, 1 is also a solution, right? 1 is less than or equal to 2. That's true. -4 is another solution because -4 is less than or equal to 2 is true. 1.99999 is another solution, right? Because 1.99999 is less than or equal to 2. That's true. So you can convince yourself pretty quickly that the very simple linear inequality x less than or equal to 2 is in fact an infinitely many solutions, right? It has infinitely many solutions. This is typical for algebraic inequalities. Most linear equations in one variable have exactly one solution. We have seen at least one solution where a linear equation might have infinitely many solutions, but in that case, every real number is a solution. The easy inequality we were considering x less than or equal to 2 has infinitely many solutions, but not every real number is a solution. For example, 3 is not a solution because 3 is not less than or equal to 2, right? That's a false statement. All right. So every simplest linear inequality poses the following question for us. How can we solve the inequality, find all the solutions when there are infinitely many of them? How can we indicate which numbers are solutions and which are not? To answer these questions, we will introduce a technique that will be useful in a number of situations, graphing. All right. So to graph an algebraic statement means to draw a picture of all the solutions. Typically, our picture will involve our standard method of visualizing the real numbers, the number line. So solving and graphing are really the same type of problem, finding all solutions, but let me finish this. The answers is written differently. All right. So we're going to look at an example of this. All right. So our basic method for graphing algebraic statements, right, will be to indicate solutions on a number line with a solid circle. In this case, right, that we have many solutions infinitesimally, all right, close to each other, we will look like a solid shaded line. So here's an example that we've been considering so far. So graph all the solutions of the inequality x is less than or equal to 2. All right, so I have x is less than or equal to 2, right? So what I'm going to do, I'm just going to make a number line, right? Let's just say hypothetically speaking that that's 2. You know that the next number over here would be 3, 4, 5, 6, 1, 0, -1, -2. You get the idea, right? And I put 2 in the middle, right? According to what we're saying here, because this is less than or equal to, we want to do a dark circle here, just like that, right? And then it's less than or equal to, so we're gonna go where? To the left. And that's it.
Question.
Mhm.
What made you want to start -2, -1, 0, -2, and not like in the way?
I just started with 2 in the middle, and then I just counted to the left by 1. Yeah. Mhm.
Let's say this will be positive and greater.
Greater than or equal to, then I would go to the right. Yeah.
So when the equals, you gotta put it in the dot. What if it's just first and equals? Just put the line.
If it was just the equal sign, it would be just that number. I couldn't do this. Like you're saying, if it was x equals 2, like this?
No, if it was just like X is X is greater.
Or like this, you mean?
Yeah.
So with that, it would be an open circle. Right? So like this.
Okay.
Yeah, yeah.
Wait.
Inequalities, graphing inequalities.
There's
Yeah.
different ways to like categorize. If it has like an equal sign, then if it has like it's greater, less than, but it has like a line above.
Exactly.
So it's a dot. Wow.
Mhm.
It's just like that. It's just an open so.
Right.
I'm sorry, probably just said this. The close is when it's not no equal, right?
Right.
Okay.
Yeah.
Okay,
Yeah.
can you tell me what that line under that?
That means that 2 is included in this answer, right? So it's 2, 1, 0, -1, etc. If it was open like this, then 2 is not included in there. Mhm. Yeah. So the line means that 2 is part of the conversation. Without the line, 2 is not a part of the conversation.
Wait, so if it's greater than. Wait.
Yeah. No, this is less than or equal to.
Less than or equal.
Yeah.
So that's what it means.
Mhm.
Less than or equal to. I'm right now, we're getting like getting shit on the board.
Yeah.
I'll do a whole video. Now, what you just said is not be totally low.
So let's say, right, let's say, for example. That's less than.
You see, that's written the other way. That's x greater than or equal to 3.
Yeah, just like another example.
Got you.
So it's like. One here. You know, and offset.
Mhm.
So it's. Off.
That's about. What if you start at 3 and go up?
Mhm. For that example.
Yeah, before the negative. This is what negative, like you said, for instance. It's gonna be positive 3, so it's gonna be 12 weeks,
Exactly.
and it's just gonna go this way.
Exactly. That's it.
And if it's not like this, it would be.
An open circle.
Open,
Yeah.
so.
But it's never gonna be open, right?
This is
It can be. Yeah, depending on the question.
So as an example, this,
It'll be open if you.
these symbols would be enclosed. These symbols would be open. Right?
Yep. Mm-hmm.
So,
Mm-hmm.
so this is not even less than equal to.
This one is equal to the one that he just did,
Oh,
yeah.
no, this is like another separate example. So. I just maybe, so I can just understand it better.
So if it says like a 4, you just go to 4 and go up.
Mm-hmm.
And then whatever it says
Or
-2, you go -2, and you go, depending on where the arrow is, you go
Mhm.
up or down, right?
Mm-hmm.
But how you know when it's equal to?
It would say it. It would say like the two equal
But
lines.
it looks like it will just give you like the thing, you just gotta like chart it.
But you put
Yeah.
I think, the president.
Oh, no, it's just like, it's a whole different example.
It's like, right, all right, so look, y'all know with that, the top part, the greater than part, right? Yeah. And you know the equal sign, just imagine them having sex. And they have a baby, so that means that. Well, as long as it's that, it's gonna be whoever. All right, let's say 2, you start a party this time, like he did, start on 2. And you guys, whatever, and now you gotta go up more, but you still start at 2, as long as that equal is there, that's where you start, that line is like basically like the point where you start. But if they don't have that line, then you, everything other than, it's like, don't touch me. That's,
I get that, that's the understanding I got, but he just said something else, he said that also means that that's part of the equation.
It's part of the set of
That's
numbers,
part
yeah.
of the set of numbers,
Yeah.
so then, yeah, what does that mean? Yeah. Like, that's what I'm like.
Because
We're
when
gonna get another question and I have to think of a different question within that concept. Instead of just thinking greater than equal to or less than equal to. You know, just, you know.
like basically like when I say a set of numbers, this particular inequality, like I have many answers. All the numbers that are less than 2 is an answer. 1, 0, -1, -2, -1,000,000, those are all answers to this. But when I say less than or equal to, I'm telling you that 2 is part of that set of numbers. So 2, 1, 0, negative, whatever.
Equal to the number.
Right, it's part of the numbers. Yeah.
that number.
Yeah.
Basically, the numbers or whatever side.
Yeah, basically, yeah. Mhm.
So what will ever be equal to?
What in certain questions, like if I had
Like, good.
x equals 5, like that's equal to,
Okay.
yeah,
Like this question.
like a single
So
solution.
this would be considered equal to, or is this like?
That's greater than equal to, yeah. Yeah, so you got to put that in your answer. It can't just be less than, it got to be less than or equal to.
Oh.
Yeah. So in the graphical method for solving linear inequalities, special attention must be given to the broader value. Consider for example, the strict inequality x is greater than -3. In this case, any number to the right of -3 on the number line will be a solution. The border value of -3 is not a solution, however, because -3 is not greater than -3. It's false. In order to deal with the problem of shading every value to the right of -3, but not including -3 itself, we indicate the border value with an empty circle, right? Oh. Mhm. Go ahead.
When you highlight certain words, what does that mean?
Pay attention to that. Really important. And when you see me skip, it's like, mhm. So hence the graph of all solutions for x greater than -3 will be open circle at -3 and then going straight to the right. Mhm. No closed circle. Yeah. So closed circle is when it's equal to.
Yeah, also has
Yeah.
like the mouthpiece and like the line, that's the close circle. It's just like the mouth, that's what we.
Ah, I understand now.
Yeah, I can't lie.
Okay,
The marker can help a question.
closed circle is when it's drawn in, right? When it's drawn in,
Yeah.
closed circle.
And now I'm looking over here, I'm looking at it, really understanding what this means.
I
So
got you.
closed circle is when it's
When it has like the mouth and the line,
and the line.
open circle is just the mouth.
Mhm.
But they both could have equal to it, right? Or those one with the line doesn't have equal to it.
They both could. It's a possibility.
I get it. You wrote that.
Yeah,
That's no.
I'm happy you did though.
Just, I feel like they just, this we can separate it in the next slide.
It's okay. So border values for linear inequalities in one variable. So for strict inequalities, less than, greater than, the border value is indicated with an open circle. For non-strict inequalities, less than or equal to, greater than or equal to, the border value is indicated with a solid circle. Right?
Straight.
Mm-hmm.
What makes them strict and non-strict?
They'll tell you in the question. But it's really the inclusion, right? If the number that's there is going to be included or not. All right. So in order to solve more complicated linear inequalities in one variable, we will present two slightly different methods. Each has some advantages. Both will rely on the methods we have already developed to solve linear equations in one variable, namely the addition and multiplication principles. The main difference between the two methods will be in deciding which side of the border value to shade, right? So let's look at the first method. So this is solving linear inequalities in one variable, test value method, right? So as the above simple example show, graphing an inequality has two key steps: finding the border value and deciding which side of the border value are solutions to the inequality. Our first method of solving inequality separates these two steps. The main idea in this method is that the border value of the linear inequality divides the number line into a greater than side and a less than side. Relative to this inequality, the border value corresponds to the solution of an equation. So we will determine the appropriate side to shade by choosing a test value, which will determine which side is which, right? So it says graph all solutions to this inequality, right? So, so basically what you want to do is just solve for X and then you'll know, then you can just choose a test value to test and then you're good to go. All right. Let's go over this. Okay, so I have 3 times X plus 2. I'm just copying it. Minus 4 is greater than 2X plus 8. Right? Long story short, I want all my X's on one side, all my numbers on the other. So distribute this first. This is 3X plus 6 minus 4 greater than 2X plus 8. Combine like terms. 3X plus 2 greater than 2X plus 8. Right? Subtract 2 on both sides. Subtract 2X on both sides. So now,
You know, the first time, yeah,
Mhm. 3X plus 2 was given to me. Right here.
Oh,
Come on.
put the arrow, that means multiply.
Yeah. Mhm.
I see the equation after 3x plus 6.
Mhm.
Like, how do we get the
It was given to me in the original question. 3 times X plus 2.
Oh,
Yeah. Yeah.
So 3 times X becomes 3X.
Right. And then 3 times 2 is 6. Mhm. Mhm.
it's only 3x equal to my just.
Mhm. Because 3 minus 2 is 1. So now I have X is greater than 6. Right? So I want to, what's up? Mhm. So now I want to graph it. That's the name of this game, graphing it. Huh?
Yeah,
Oh,
this would be like.
6 minus 4 is 2.
Yes, this would be an open circle.
Mhm. So open circle, right?
It would be an open circle.
But let's just say hypothetically speaking, right? Let's say that this is 6, right? You know, this is gonna be 7, 8, 9, 5, 4, 3, right? Now, as you said, this is an open circle, right? But go ahead.
This is a 6. 6, 8.
8 minus 2. Now, let's just say hypothetically speaking, I don't know which numbers are bigger than 6, right? So what I could do is I could find a value, a test value, to test it to see if it works, right? So like let's say I choose 8, right? Is 8 greater than 6? That's true, right? So I know that definitely I want to go towards 8, right? Let's say that I choose 4. Is 4 greater than 6? No, right? So that's how I know, right? Not to the left. Mm-hmm.
How did you go from 3X negative 2X to it just being X?
3 minus 2 is 1.
Or 1X, I mean 1X.
Also,
Yeah, anything times 1 is just itself, right? So I know what I have to go this way. And then that's it.
okay, so 1x is just an x value,
Mm-hmm.
so 1 is just an x.
So, right, greater than 6. It might be. You have the algebra formula sheet? It might be.
I got it.
Inequalities? It's a good question. Let me see. I gave it back. It's running the truth. It's running the truth.
What's the name?
Inequalities.
This is some point in the sheet. You want the big packet?
Yeah, this one's not in it. No, it's not in the big one. The big one's just.
Why did you put eight is greater than six or four is greater than six?
Because I'm testing the values to see where I have to shade. Should I shade to the right or should I shade to the left? You know? So right. But assume I didn't know that. I would this is one method. This is the test method. I pick a number and I try it out to see if it works or not. Right?
But you don't need to do that, right?
You don't. Mm-hmm. So what you're describing actually is test two.
Look,
Test two is when you just look at it and it says greater than, so you know to go to the right. That's test two. Test one is just you like you don't know it kind of thing. So you're trying to just playing with the values so that until you can see if you get the right thing, you know? Excuse me.
what if it has like greater equal to? It would be a circle big, right?
Mm-hmm.
And it would still go up.
Mm-hmm.
So what's the difference?
Between greater and less than?
No, it's like full stop. They literally do the same thing.
So one of them is including the value that's there and one isn't. That's the difference. Like in this story, right? This is not it's not including six, right? So it's all the numbers that are bigger than six. So 6.1, 6.2, 7, 8, 9, 10, 1,000,000, 3,000,000, right? It's all of those numbers, but not six itself, you know? That's what that means. Yeah, I blame the weather, man. They got all of us in this. Yeah. We not supposed to have allergies in the winter. The winter's supposed to kill all these damn flowers and the insects. It's supposed to send the insects back to hell. You know? So look, we have right here our number line, right? We know that six is greater than six. Boom, open circle, right? We test the number like the number four. We just plug it in here and we see that four doesn't work. So that's not where I should be shading. I should shade the other side, right? That's what it means by test value, right? So the test value method for graphing linear inequalities in one variable, how you do it is first you find the border value by solving the corresponding linear equation, right? Step two, you determine which side of the border value to shade by choosing a test value and deciding whether it is a solution or not, right? Represent the border value with an open or closed circle according to whether the inequality is strict or not, all right? So let's look at another example. Say we want to graph all the solutions of this inequality, right? Same kind of question, right? I have 2x minus 3 plus 3x less than or equal to 10x minus 5. Same thing. Distribute gives me 4x minus 6 plus 3x less than or equal to 10x minus 5. Combine like terms, 7x minus 6 less than or equal to 10x minus 5, right? Say I want to subtract 7x from over here. Am I? Add 5 over here. Really? Okay, okay. Don't worry, you'll catch up. -1 less than or equal to, what's this, 3x? Divide by 3. Should do the one side, do to the other. Final answer, x is, here we go, greater than or equal to -1/3. 7 from the 7x. So 3x plus 4x, 7x.
Okay, I got like.
Mhm. And then what am I gonna do? I'm gonna graph that answer that we just found, which is the 1/3. And then I'm gonna shade either to the left or to the right. That's it.
Can we do the color?
Uh-oh. That'd be nice though.
So where you got the number?
3x plus 4x, 7x.
3x plus 4x?
Mhm.
So why you just do it like that?
They're like terms, combine like terms.
Let me break that down.
Okay.
So because this number is up, what's up?
Do the opposite side.
3 plus 5.
5, yeah. I know my fives are jacked up. Long story short, I want all my variables on one side and all my numbers on the other. That's why. So if you wanted to do it in reverse, completely fine.
What? 6.
5.
There's no way that's a 5 for
Yeah.
That looks like a. I don't know what that looks like. Wait, but why?
It's supposed to be
would you put
that.
five there?
Because I eliminated it here. I added 5 to the -5. But what I do to one side of the inequality, I have to do to the other side of the inequality.
Oh, so you do the ones that are in like terms, you do the like terms, you flip them over, then you do the ones that not like terms.
Right. Mhm.
Well, now we'll give you-
Mhm.
Let me write that down. See, you gotta say go to the.
After that, you already know. So this is gonna be -1/3. Let's see over here. This would be like 0. Over here, this would be like, I don't know, -1. You get the idea. All right.
No.
Was this gonna be an open circle or a closed circle? Good.
And
And where am I going? To the left or to the right? To the left? Up, right? So I'm going this way. Mhm. Oh yeah, yeah, true. Yeah. Mhm. So that's that.
The like term, if you don't wanna go to the other side, stays a negative, because you turn the +7 into a -7.
Right,
And then we flip it over, it stays the -7.
right. Mhm. So now you guys have seen the two techniques, right? One technique, you could just read the question and that's it. Another technique is if you don't know, you take a test value, you plug it in, and you see if it works. All right. This is very important for calculus. All right.
Which number is test?
Y'all not gonna switch out major? So the test value, it's up to you. Test whatever you want. Right?
1/3, where did you get that 3?
It's because 10x minus 7x is 3x. And then I divide by 3 to get x by itself. But what I do to one side, I have to do to the other. Right? So I could have tested anything. I could have tested -1, for example, right? Is -1 greater than or equal to -1/3? Right? This is a false statement, so it's not true. Right? -1 is more negative than -1/3. Right? We rather owe 30 cents than owe $1. That's what that means. Right.
Oh,
Mhm.
so because the 7 went into the 7 evenly, the x is gone into
Um,
the -1.
yeah. So the 7x and the 7x canceled out. So it's just -6 plus 5. So that's just the
Because they
negative.
keep it,
Mhm.
so 7 minus 7 is 0, so the x is extinguished. For the other side, there's still a remainder, which is
Right.
three. And the back.
Exactly.
I say it out loud, so just,
Works.
or.
Works.
So why did you put X is greater than negative? Why didn't you just leave it the way it was?
Read it backwards. I like to put my X's on the left. You know, even when I'm walking down the street with the X, I put them on the left. You know, that way if the car splashes, it hits them, not me. You know, yeah. They're X for a reason, you know. So
Wait, but why did you flip it?
huh?
Why you flip?
I read it backwards, that's why. So you see how this says X, like instead of reading from like -1/3 is less than or equal to X, read it backwards. X is greater than or equal to -1/3. Yeah, if the X is on the right, you know. Otherwise, you could just leave it on the left. Yeah, yeah. X is not really an interval. It's a whole bunch of numbers here.
What is it?
No, I mean, if there is an interval, the interval would be something like this. It would be like bracket -1/3 all the way to infinity. That would be the interval. Yeah. Hmm. Interesting. Okay. So that could be something like this. Yeah, that's possible. Whenever you have a closed circle, it also corresponds to the bracket as well. You know, open circle corresponds to a parentheses. Mhm.
It's an infinity, what is this?
Infinity is all the numbers that are getting bigger and bigger and bigger. Yeah. Yeah. Yeah, it's a sideways eight. Yeah.
Is it the same as what we did just now?
Mhm.
It's not a funky, weird way to know,
Yeah.
right?
It's not.
Okay.
There's harder questions in the homework. I mean, I have more examples though. I didn't finish all of my examples. Graphing.
Like, look.
Got you.
It says the type or interval is
Are you
incorrect.
gonna do another one?
What is the interval?
Let's see. Is that number 4? Okay. All right, so divide by 4 on both sides. That's gonna be 6, right? Nah, but look, this is less than or equal to, and you got less than. Like, copy it. Make it less than or equal to. Yeah.
But
Yeah.
what is the interval though?
No, it's this thing. It's supposed to be less than or equal
This
to.
symbol, this right here is
Yeah,
the
yeah.
interval.
Yeah, that's the wrong one. It needs to be less than or equal to. Yeah. Like literally just copy what's there. And that's it. You know? So nah, you be right with your stuff. It may just be like something a little bit off, but you're right with what you do most of the time. Here's another question, right? Kind of not fair to ask this because it's a lot easier than what we did before, but you got 4x minus 7 is less than 2. We want to graph this, right? What am I going to do? Add 7 to both sides, just do to one side, do to the other. But now look what I got. I got 4x is less than, is that 9? 7, 8, 9, something like that, right? Then I want to get x by itself, but look at this. I have a number being multiplied by the x. So what am I going to do? I'm going to divide by it, divide by 4. What I do to one side, do to the other. So now I have what? X is less than 9/4, right? Now you already know what's going to happen here, right? We're going to graph this. There goes a 9/4. Let's say that this is like 3. Let's say that that's 2, something like that, right? And then we're going to have an open circle, right? Open circle. And then we're going to go where? To the left or to the right? Less than or greater than? Which one? Less than, right? So we're going this way. Yeah. Right. And like I was saying, this also corresponds to a parentheses. All right, so if this was an interval, it would be what? Open parentheses, negative infinity to 9/4, close parentheses. That's a 4. All right. A little bit of overkill, not asking you all of that, but I am showing it to you guys. All right. Just talk a little bit more about method 2, even though I already showed it to you guys, just so that we all on the same page. All right, so solving linear inequalities in one variable, standard form method. Another way of deciding which half of the number line to shade for a typical linear inequality in one variable is to take advantage of the special form x is less than whatever or x is greater than whatever, right? We will call this form standard form, in which the variable appears on the left side of the inequality by itself with no operations. So we open this section by considering an example of this form, x is less than or equal to 2. The graph consisted of shading all the values less than to the left of 2, along with the border value 4, which we indicated with a solid circle. All right. So let's look at over here. X is less than or equal to 2. Solid circle at 2, shaded to the left. Right? So on the other hand, we considered the inequality x is greater than -3, also in standard form. The graph consisted of shading all the values greater than or to the right of -3, with the border value -3 indicated with an open circle to indicate that it is not a solution of the inequality. So x greater than -3, open circle at -3, shaded to the right. All right.
So we're gonna start at -3, right?
Right.
Always start in the number they show you.
Right. Mhm. And then decide if you're gonna go left or right.
But the side tells you.
Tells you what to do. Exactly. So you don't gotta memorize it. Sure. Well, this thing? Okay. Any questions, anybody? It was good? All right. I'm getting to it. But it's not bad, right? This section? It's-
You're so used to doing it one way, that you don't hold on the problem,
Mhm.
that you have to do it a little different way.
Wait, let me do
I
the.
got you. It's okay.
I got a question, like, instead of inside the parentheses as being 2x, it says x.
Like x equals x?
No, it's 2 parentheses, x plus 5 parentheses. Yes, and 2 7x plus 5.
So distribute, combine like terms, like what I did in the previous question.
Yeah, but it's different. So are we doing 3 times 5?
Yeah, distribute them both to both terms and then combine like terms. You good? No?
Thank you. You know, it's x right here,
Mm-hmm.
but then I did the 2 times 5, right? That's these two.
Mm-hmm. So this is 2x plus 10, less than or equal to 7x plus 5. And then just solve for x.
So that's where it makes sense from.
So distribute the 2. Mhm.
So it'll be 2x times 5?
2x plus 10. 5 times 2.
That's to the 25.
No, not 25. 2 times 5, so 10. Yeah. Hi, how are you? Yeah. Yeah. Hey, what's up? Not today, next week, Tuesday.
Even if I would have came.
Yeah, next week, Tuesday. Because then I have more time. I can come in early, I can leave later. Yeah, but I have another class after this, that's why.
Thursday, you do?
Thursday,
Tuesdays.
Tuesday's about it.
So you have to. Everybody.
Not on Tuesday.
Okay.
Yeah, only on Wednesday and Tuesday. Oh, by the way, y'all, since I got all y'all here, he's coming? Yeah. Eventually he'll come. So yo, listen, tomorrow they got a jollof rice competition in Colston lower level. Y'all should all go. Jollof rice. It's like African rice. Yeah, that thing. I can't say it. Yeah. It is. Yeah. It's a competition. Different countries versus each other. Yeah. Yeah.
No, they gonna say something.
Mhm. It's a competition. Which country did it better? You know?
We don't know when you said you were gonna do the next day, right?
Mhm.
No,
Inequalities.
something else. Something about the problem. Yeah, but it's
Yeah.
allergies, but it's not all the.
Yeah, yeah. I'm just telling y'all to get y'all free food tomorrow. That's it.
Right.
Yeah.
What time is
Yeah.
it?
It's 12 to 2. Yeah. Mhm.
Don't even give me my.
Not tomorrow, maybe like Wednesday next week. Yeah. Yeah, I need time to grade it. That's why. Yeah.
Oh my gosh.
All right. Our second method of solving linear inequalities in one variable will be to convert the inequality into an equivalent one in the standard form with the variable by itself on the left side of the inequality in almost exactly the same way as we did solve a linear equation. In that case, we can follow the rules. For inequalities in the standard form, x is less than or equal to a or x is less than a, we always shade to the left of the border value of a. For inequalities in the standard form where x is greater than or equal to a or x is greater than a, we shade to the right of the border value of a. What?
So, just going to the right is greater to the left,
Mm-hmm.
going to the left is greater to the left.
Yeah. Mm-hmm. Yeah. Simple stuff. Simple stuff. So as usual, right? The border value of A will be indicated with a solid circle or an open circle, depending on whether or not the inequality is strict, right? Equal to or not, right? The standard form method has the advantage of the word always, in particular, because we take the trouble to write the inequality in the standard form. There's no need to choose a test value to determine which side of the border value to shade, right? So there are two important points that need to be kept in mind, right? However, the first is that the standard form presumes that the variable is by itself on the left side of the inequality. When we solved equations, we were free to choose to write the variable by itself on either side of the equation, right? In fact, we saw examples where it's more convenient to write the equation in an equivalent form with the variable by itself on the right side of the equation. The problem is easy to solve as long as we keep in mind that writing A less than B is the same thing as writing B is greater than A, right? They're mirror images of one another. You read them backwards, all right? So in other words, writing the inequality from right to left changes the sense of the inequality. In other words, the inequality symbol points in the opposite direction. So if we were to rewrite the linear inequality into the form 5 greater than or equal to x, right? We would simply rewrite it in the standard form, read it backwards, as x is less than or equal to 5. Right? Mm-hmm. Yeah. Mm-hmm. So as long as you know that, you good. Mhm.
X is less than or equal to. So the X is less than or equal to 2, you want us to put this graph, right?
It helps. Yeah.
Yeah, 2 or less, okay.
But always flip it, right?
Greater than.
Mhm. So the second point to keep in mind is more serious. The careful reader might have noticed that this method was described as rewriting the inequality in standard form in almost exactly the same way as for linear equations. More specifically, that means using the addition and multiplication principles to do the same thing to both sides. To obtain a simpler statement, in fact, the addition principle can be used in exactly the same way, adding or subtracting the same quantity from both sides of the inequality produces an equivalent inequality, an inequality with the same solutions. All right? Two.
Press with the left hand or equal to 2, you have to stop at the -2.
You start at the -2, and then you decide if you're on.
Start in positive, so.
Oh, she's talking about the low parts of the program.
It was -2,
X is
less than or equal to 2.
So it
Yeah,
starts from 2 and
from
it
2,
can't pass 2.
and then right, and then go to the left.
But you
Yeah,
have to stop here, or you just, it's infinite.
it's infinite. Just keep going.
Oh.
Yeah.
I don't remember this.
1 sec. I'm gonna go back down and listen. All right. The multiplication principle requires some adjustment, however, right? So to see this, let's start with a true inequality. 2 is less than 3. Multiplying both sides by 5, for example, we obtain that 10 is less than 15, which is still true. However, if we multiply both sides of the inequality by -5, what we get? -10 is less than -15, which is false. That's not true, right? I'd rather owe $10 than owe 15, right? Clearly, multiplying and dividing, as you might have guessed, by a negative quantity has a different effect than multiplying or dividing by a positive quantity. So without going to a lengthy explanation for why this is so, just keep in mind that multiplying by a negative quantity involves some sense of an opposite, and additive opposites on the number line are mirror images of each other, reflected across the point representing 0. For this reason, we need to adjust the multiplication principle for inequalities. So, the multiplication principle for inequalities. Multiplying or dividing both sides of an inequality by a positive quantity will produce an equivalent inequality. It'd be the same thing, right? Multiplying or dividing both sides of the inequality by a negative quantity will produce an equivalent inequality after changing the sense of the original inequality. When you multiply or divide by a negative, you flip the sign always. All right? You multiply or divide by a negative, you flip the sign. Sure, I got you.
So we just note this part right here instead of
Mm-hmm.
waiting by minute there.
Mm-hmm. I thought I was the only one.
I took this question, I forgot this one.
So, for example, dividing both sides of the inequality negative 3x is greater than 6 by negative 3 gives the equivalent inequality, right, of negative 3x divided by negative 3 less than 6 over negative 3, x is less than negative 2. The sense of the original inequality has changed from greater than to less than, right? You flip the sign. With these two small adjustments to our method of approaching linear equations, let's go back to some examples we saw in the test value method, right? So remember I had this one, the 3 times the x plus 2 minus 4 greater than 2x plus 8. So watch what happens now, right? Distribute this. 3x plus 6 minus 4 greater than 2x minus 8. Good. Mm-hmm.
Why you show them like this?
What do you mean?
Like,
With the test method? It's another method. That's why. It's two different methods. Yeah, you could choose whichever one you want, though. You don't have to do both methods. Yeah. Yeah. So then we have 3x plus 2 is greater than 2x minus 8. After that, subtract 2x from here, right? And then we're going to subtract 2 from here. So now what do I have? I have x. I don't know why this is like acting up like this. Excuse me. Yeah. This sucks. So x is greater than negative 10. This is a bad example, but y'all get the idea. I got a drink here. I don't know. Something's working. I might have wrote it wrong. I don't know. Yeah, I wrote it wrong.
What do you mean you wrote it wrong?
That's plus 8.
one X is less, I was like, greater.
Because it like selected it instead of erasing it. That's why.
No, don't be. Oh, what are you doing?
It's the same, no, it's the same thing. You doing it.
Oh, what are you doing?
I don't know why it's freezing all of a sudden. Okay, there we go. There we go. Plus 8, 6. There we go. There goes 6. X is greater than. So that's 7. That's 5. Uh-huh. And where am I going? Good. This way.
And there's an open circle, this is a little left at the line.
Mm-hmm.
Can you go back up so I can copy that?
Sure.
Can you put this in the calculator?
I wish, no.
No, right?
Yeah.
This is like the simple algebra.
Yeah. Not
Okay,
bad,
so I
though.
got
No, but it says graph though.
Mm-hmm.
I got confused with that wording. It says when you multiply or divide positive,
Mm-hmm.
equivalent inequality is what?
It's the same thing. It doesn't change. Like you just keep it the same. Hold on a second.
So the ones you highlighted?
So when you're multiplying, okay, when you're multiplying or dividing by a positive number, right? The inequality stays the same, it doesn't change. But when you multiply or divide by a negative number, you have to flip the inequality. That's what it's trying to say.
Like this? You see this?
Yeah.
This is what?
Mhm. This was a bad example because I didn't have a negative to divide it by or multiply it by. But if I did, I would have.
If this was a negative two?
If
me?
the number in front of the x was negative, then I would do that flip.
This.
Yeah,
It would have been a positive.
yeah,
Oh, I see.
yeah, yeah.
Oh, what is it
Mhm.
next? You have to flip it.
Right.
So whatever's negative in front of the variable, right?
Yeah. Then you just divide by it and it flips it.
That's the letter.
Yeah.
It's
That's what
negative,
you're
you
gonna
flip it.
divide by. Yeah. Flip it, yeah.
5 is greater than x,
Mm-hmm.
and x is greater than 5, that's the way you flip it, right?
Mm-hmm. That's it.
Well, what if we have examples? For
Mhm.
like, for the test in the future or anything? You see how,
Yeah.
can we bring that as like a study guide?
You could ask me about it, sure.
Cause I feel like when I'm in front of the test, it needs, but if I write an example, like.
Why? It's the
I don't
same
know.
questions.
It
It
was
shouldn't
dope.
leave.
Like if I
That's
see it
true.
before, and you see like this is an example.
Yeah.
Test different levels.
Mhm.
I'll be like, okay, I know what I'm doing.
Mhm. Okay.
Following the.
Okay.
So 5 is the
Mhm.
fit for us, right?
Yeah.
We already did it, but what changed?
Nothing. It was the same thing. The same thing. Good. All right. See y'all. See y'all. I'm just gonna finish this up real quick. Y'all could watch it on the video. Same thing, right?
It showed the, right?
But the first time we did it, we had the test value, and now we don't care about the test value. Yeah. Like when you plug in a number to see if it works or not. That's a test value. But you automatically were doing it the second way. You were just saying, oh, it just says greater than, so I just do that. That's fine. Yeah. Yeah. All right. So summarizing the standard form method. So standard form method for graphing linear inequalities in one variable. You can use the addition principle and modify multiplication principle to rewrite the inequality in standard form with the variable by itself on the left side of the inequality. For inequalities involving less than, right? Less than or less than equal to, shade to the left of the border value. For inequalities involving greater than or greater than equal to, shade to the right of the border value. Represent the border value with an open or closed circle according to whether the inequality is or is not strict, equal to or not equal to. It's a summarization. Yeah. So let's apply this method in two examples we saw previously. So here we go. I have one example. Let me see how many more examples I got real quick. I think that might be my last example. Mm-hmm.
Like greater?
Mm-hmm.
No. Yeah, because you flipped the sign.
Yeah. All right. Since I did these examples already and time is running, you guys already have the solutions for that. Let me just give y'all a final summary and then we'll call it at that. All right. All right, so to summarize, right? A typical linear inequality in one variable will have infinitely many solutions. For this reason, the solutions are typically indicated with a graph on a number line. The typical graph of a linear inequality will be half of a number line, all points to the left or to the right of the border value with the shaded region representing solutions to the inequality. The border value is indicated with either an open circle in the case of a strict inequality, less than or greater than, or with a solid circle, right, in the case of a non-strict inequality, less than or equal to or greater than or equal to. Which side of the border value to shade can be determined either by the test value method or by the standard form method. Keep in mind that an inequality, like an equation, can be an identity, and so all real numbers are solutions or a contradiction, and so has no solution. All right, that's it. Cool, cool. That's it. Have a great night, y'all. And then I'll see y'all tomorrow. Yep, homework's on this already. Thanks. Let me see.